Hi and welcome to my second tutorial of fractional decomposition. And in the previous tutorial I took you through the basics of fractional decomposition. I know it looked easy and simple. However, there are situations where things can be very complicated. But the most important thing is you have to know that you can only proceed with fractional decomposition if you have a proper rational expression, which means the degree of the top is less than the degree of the bottom. And the top, I mean numerator and the denominator. Here are examples of proper and improper fractions. This one is the proper one, and this one is the improper fraction. So the degree here, and the degree here, and the degree here, and the degree here. So what you have to do is you have to consider that any fractional decomposition or the denominator must be of a higher degree than the numerator. If you get something like this by any chance, definitely you have to go through long division, then you do partial fractions. In my next example, I'm going to show you something that looks a bit complicated, but I will try my best to make sure that you understand how to compute and solve for it. So let's go ahead and put down this equation. 2x plus 3 over x plus 2, x minus 3. Now, in some situations, you may be given a quadratic equation in the form of ax squared plus bx plus c, whereby you have to find the two values of x, and definitely usually comes in form of factors where x plus 1 as a solution or x plus 3. These two are the factors of the quadratic equation. Now, if you're given this before you do your calculations, you have to convert it into factors before you proceed. So let's go ahead and do the magics here. Now, the first thing we do here, we know the denominator has three factors. Therefore, we have a, the denominator x plus 2, x minus 3 is our common denominator. We therefore multiply in both sides of the equation. Okay, let's go ahead and cancel out. So our equation remains as 2x plus 3 equals to a, and then we have x plus 2, x minus 3, and then we have b, this is plus bx, then x minus 3, and then we have plus c, x, and then x plus 2. Right. I know in the previous equation I mentioned that you don't have to expand it. Likewise, you don't have to do the same for this equation. And I know it sounds weird because these are multiple equations in one. How do we solve it? Hang on, this is the video. I'll reveal the secret on why you should never freak out on fractional decomposition in a math class. So for now, what I'll do is I'll use some values to give the constants. Then at the end of the video, I would explain why I picked those values. So let's go ahead, and I will pick my first value when x is equals to 0, right? So we rewrite the same equation. We put 2 multiplied by 0 plus 3 equals to a, 0 plus 2, 0 minus 3, plus b multiplied by 0, then 0 minus 3, plus c multiplied by 0, in brackets 0 plus 2. Okay, let's do the magic cancellation. Now you realize that any one number multiplied by 0 will go, this will go, and this will go. and then this one will solve for our first variable, and the first variable is a, so this also goes. So our equation becomes 3 is equals to minus 6a. Therefore a is equals to negative 1 over 2. So this is our first solution for a known variable a. Okay, so let's go to the second magic. Let's pick a number, and the number I'll pick in the second equation is when x is equals to negative 2. As I said, don't worry, I will explain at the end of the video why we are picking these numbers. X is equals to negative 2. Okay, so we have 2 multiplied by negative 2 plus 3 equals to a, and then we have minus 2 gets minus 2 minus 3 in brackets minus 2 minus 3 plus c in brackets minus 2 in brackets minus 2 plus 2. Well, I know it's getting longer and longer, so let's go ahead and cancel the numbers that are gone. And here we see this cancels out and c cancels out. Okay, so our equation goes to the simplified version. We have negative 4 plus 3 is equal to 10b. Okay, therefore we have negative 1 is equals to 10b. Hence b is equals to negative 1 over 10. Here we've solved for b, right? Okay, now let's pick the last value when x is equal to 3. So we go ahead, as I said, I will explain at the end of this tutorial why I'm using these values. Then 2 multiplied by 3 plus 3 equals to a plus 2, 3 minus 3 plus b multiplied by 3 in brackets 3 minus 3 plus c, we have 3 multiplied by 3 plus 2. Okay, so we go ahead and do the cancellations. This goes, remember, because 3 minus 3, and also we have also 3 minus 3 on this other side. Therefore our equation is reduced to 6 plus 3 is equals to 9 is equal to, we can see here this plus this is equals to 5. 5 multiplied by 3 is equals to 15. So we have 15c. Okay, therefore c is equals to 9 over 15, which is equivalent to 3 over 5. Cool. So that is our last solution. Now plugging the value to the equation, we have negative 1 over 2 over x plus b is negative 1 over 10 over x plus 2 plus 3 over 5 over x minus 3. We have negative 1 over 2x plus, instead of putting a plus, I'll put my negative because this already, the top version is negative. So we have 1 over 10 in brackets x plus 2, and the last one is 3 over 5 x minus 3. Cool. So what we have here is our final answer, and solution to the problem is negative 1 over 2x minus 1 over 10 in brackets 2x plus 2 plus 3 5 x minus 3. Now let's quickly revisit. Why did I use these figures? It looked like I didn't have any efforts. Did I pick any random value? No. Remember, whenever you have a question in terms of factors. We'll go ahead and use those factors. You can see them, right? You'll realize in every situation we have x. The first factor is x, the second factor is x plus 2, and the last one we have x minus 3. Okay, well, all we have to do is we have to equal to 0, equal to 0, and put equals to 0. Then because the first value of x is already 0, then I don't have to do anything. Okay, I'll leave it as it is. But whenever the second value, the x is equals to minus 2. Okay, this is the factor. If I solve for x, x is equals to minus 2, and here x is equals to 3, which is what the values I've applied into these equations. So if you go back and revisit this, you'll see that these are the numbers that I've used to solve the equation. Okay, now this is the most tricky part of it, because I know most people will go guess and try to solve. The beauty about this is that we already have been given the values. In our top version, x is equals to 0, so we don't do anything. The second one, x plus 2 is equals to 0, then we get minus 2, and the last one is x minus 2 is equals to 3. So this is the secret, guys. I know you always find it complex, but that's what I was saying. You have to get it right whenever you see a fractional decomposition. It's as easy as it looks. Thank you.